So today we are going to solve a problem of find minimum time to finish all the job. You have given an array where job I is the amount of time it takes to complete the ith job, and you have to given k worker. You have to assign the job to the k worker such that it will take the minimum time, and you have to return the maximum working time. For example, you have given 3 job here and you have 3 worker here. So suppose there is 3 worker and you can assign the job in such a way that it will finish in a minimum time. So the optimal answer would be like you can assign the first job to this one, second to this one, and third to this one. So it is the optimal way, and from this you can return the maximum, which would be 3. Another example would be this one. So here you have exactly 2 worker, and what is the best way to divide them? It would be like worker 1 would do this job like 1 2 8, this one 1 2 8, and second worker would do 4 and 7. So both would be the 11, and you have to return the maximum. It would be 11. So you have to assign the job in such a way that is optimal, and from that you have to return the maximum. Or you can divide the question in such a way like you have given an array and you have divide the array into k sub array such that the difference between them is minimum. So let's try to find out how we can do this. So the logic behind this, I can say, suppose you have given this array and there is k worker. So what you can do, our task is to divide this array to this sub array such that the minimum difference the difference is minimum. So we can make the array of size k, which would be this one, and what we can do, we can just add particular index number to the from 0 to the k, I can say from 0 to k. So from here we will have only 2 sides, so we will have only 2 options left out. So for the first option I can say we will plus 1 would be here, another option would be like we plus 2 at this position, so it will be get 3. Similarly we will get 4 here, so we will get 7 from here, and when we plus 7 at this position, so we will get 14. Similarly we will get 18, so we will get 22. And when the ith is the like our ith position is this one, and when we again call our function, so our ith would be 5, and when ith would be equal to the length of the array, so what we can do, we can calculate the maximum from the array, and the maximum would be, I can say, maximum would be 22. So by default we can take a global variable which is minimum, which is the name of minimum, and it is value plus infinity. So when we calculate the maximum value from here, like this one, I is equal to 22. So what we can do, we can take like this one, minimum is equal to math dot minimum, I can say it is equal to minimum, and I can say the maximum is the value of the maximum value of the whole subarray, so it is the maximum. So when we reach here, so our minimum value would be updated by 22. Again we will go at here, the maximum value of this array would be 14, so again we will update this to the 14. Again we will come at this position so the maximum value would be 15, but it is not smaller than minimum, so the value will remain same. And the question is here, why we calculate maximum value when we reach I is equal to 5, so that we will let to know that we will consider all the element in our subarray. We calculate the minimum value only if our ith is equal to the array dot length, and it is our, I can say it is our array. So it is confirmed that we considered all the element in our k sub array, so we will calculate for this position only. So now we will calculate for this one. The maximum would be, I can say again, 15, so it will be not updated. Again we will come at this position and we will say that we have 11, the maximum, and it is exactly our answer. So we can update this one by the 11 and it is our final answer. We will check again, it will be the 19. 19 is the note, it is not best, so we will unchange this variable, so it is our 11. And one optimal approach, I can say, when you come at this position, you can say we can add this position to this one, but this is unnecessary work. Why? Because if you do the same work, it is basically a mirror of this work. Like you can just mirror all the subarray, so you will get the all the same thing, which is this one. So like here is the 3 is there, here 3 is there, and if you draw 2 would be there, it is like 1 and 2, so it is also the, I can say, the same work would be there, so it is unnecessary work. So how you can check this one? If your ith value is greater than 0, suppose you have your ith value equal to 0, this one, and when your ia value equal to 1, I can say 1, so it is greater than 0. So you will check, is both the values same? Initially I can say your subarray would be like this one, so if both the value, I can say, equal to same, so you will just continue the loop. And how code look like, I will also so this is a code in a Java, you can understand. I will tell you the logic behind this. You can code in any language. So what actually we do, this is our function. I can say we will make an array of kth size, so we will pass this one into this one, and our j would be initially from this position, which would be, I can say, 0, and we will pass the same array, which is this one. So we'll see this, what exactly the base case would be this, but first of all we can see this logic behind this. So what we can do, we will starting from this position and we will continue to the whole size. So and what we can do, this is the same condition which I already told you to reduce the unnecessary work. And what exactly we do here, we do the sum I plus job j, which is we do here 1 3 7 and again we will call the same function with the j plus 1, and from here we backtrack, like it is 22 here, so we will subtract 7 from 8 from here, and it will be 14, and again we will call 8 from here. So it is for the backtracking approach. And when our j is equal to job dot length, what we can do, we will choose the minimum from the maximum and minimum, and this is a function which will calculate the maximum from the array. So when our j is equal to, I can say, when our j is equal to at this position, so we will calculate the maximum from the array, and for every call we will calculate the maximum. And there is this condition also, which is try to reduce the time complexity. How? Suppose you have your maximum element would be 11 and it would be assigned to a minimum variable, which is, I can say, your minimum variable would be 11, and when you search the, when you backtrack from here, then you will certainly maybe you get such cases like 15 would be there, and I can say you can assume any number like 7 would be there, just assume this one. So when it will return the 15 maximum, so we will know that it is not our best case. Why? Because we already get the 11, this is the best case, so we did not need to calculate furthermore. So that's why we are backtrack from this position. If our maximum is greater than minimum, so we will backtrack from here, and we will only update our minimum only if our j is equal to job dot length, only at this condition, only at the last, so that all the elements would be considered in our array. I hope you understand this.